Today we're going to study a very important topic, Object-Oriented Programming, OOP. The name is self-explanatory. OOP is programming which is oriented towards objects. OOP is based on classes and objects. Classes and objects are so important that all the Java code as such is written within classes. The first thing to understand is the difference between a class and an object. A class is a kind of a pattern which is used to create an object. Let's say you have to describe a dog. So you may say that a dog is an animal which has 4 legs, a tail, fur, and this animal barks. You won't describe a particular dog, but instead you will give a general description of what a dog looks like. So you have just created a class. It is a pattern which can be used to create real dogs. So now think of the doggy who lives in your yard or your friend's yard. The dog is black and not very big. Its name is Fido. You have just described an object or, as it is also called in programming, an instance of a class. It's extremely important to see the difference. A class is something abstract, a set of some properties. An object is something specific, based on class. In general, a dog is a class. While those dogs you know, for example Fido, are instances of dog class. In other words, objects. As a rule, classes contain some data which are called instance variables or field variables, and also some code, the actions which the object can perform. They are usually called methods. Altogether, all fields and methods are called class members. Classes are created and look this way. Keyword class, then the class name with the capital letter, instance or field variables within curly brackets, and then methods. We have already created dozens of classes. Let's take a look at any one of them to see what it contains. Run IntelliJ IDEA. I have opened our previous project, Space. Let's select it, and here you can see the keyword class, the class name, curly brackets, and the method. We can click this arrow and minimize this method. Then we will see that our class does not contain any data or fields, and it only has one method which is called main. In fact, a class does not necessarily contain method main. We needed this method only to be able to run this class when the program starts. So let's see how it all works. Let's create a new project, File, New Project. Call it OOP. And now let's create a class and call it main. Our program will start with it. To make it possible, create an entry point. Let's put this class aside for now and learn about OOP. We will create a new class and call it box. You already know how to do it. Select New, Java class, call it box. This class will describe a box, which contains 3 instance variables or 3 fields, length, width, and height. Let them be of double data type. Write double width, double height, double length. So we have created class box, but we should keep in mind that it is a class, not an object. It means that we have simply described what a box should look like. No real boxes, no objects have been yet created. We will be creating objects within our class main when the program starts, or in other words, in the body of main. Open it. To control the object, a variable must be created. This variable will store this object. In other words, we must create a case for storing an object. Here this object will be box. This is done exactly the same way the primitive type variables are created. But in this case, class name is specified instead of the data type. So we should write box, the name of the variable. Let's call it myBox and a semicolon. So we have created a box type variable, but we have not put anything into it. It's empty. To create new box object, we must type myBox, assign symbol, keyword new, box, then open round brackets. Don't forget about the semicolon. Just like it is with primitive type variables, we can initialize this one either immediately or upon the creation of a variable. Let's initialize it immediately. Delete this line and assign the value newBox to the variable at its creation. These variables are called reference variables. So we have created a real box and we can assign it its sizes. In order to address the fields or methods of an object, use dot operator. Write myBox and put a dot after it. Now you can see the fields we can access, their height, length, and width. We can assign the sizes. Let's assign value 10.2 to height, 15 to length, and 11.3 to width. Now let's print out the volume of this box. Create a new double variable, call it volume, and assign it the following value, myBox.height. In order to get the volume, we must multiply height by width and by length. Multiply by myBox.length and multiply by myBox.width. Now let's print out this value. Run the program and you can see that the volume of the box is 1728.9. When objects are created, each one of them gets its own copies of the instance variables. It means that we can easily create two more boxes and assign them their own values. Let's do that. Let's create two more boxes, box 2 and box 3. Assign sizes to each one of them. Let them both be cubic. Box 2 having all sizes equal to 5. Box 3 equal to 10. Now we can display the volumes of these boxes. Let's create one more variable. Double volume 2 and assign it the value of box2.height times box2.length times box2.width. Sometimes we forget a space character or do something like this, but never mind. The code will be okay apart from not be pleasing to the eye. There's a walkthrough in IntelliJ IDEA to format it fast. When you press Ctrl-Alt-L, the IDE inserts spaces where they are meant to be, and the code looks nice. Now let's create a variable for storing the box 3 volume, volume 3, assign symbol, box 3 height times box 3 length times box 3 width. Let's print out all these values. The volume of box 1, We will print out the volume of box 2 with a new line, so type \n. The volume of box 2 \n again, and the volume of box 3. Run the program and see that each box has its own volume. It's possible because every box stores copies of its own length, height, and width variables. And these variables do not meddle anyhow with the variables of other boxes. So why are these variables, my box, box 2, and box 3, called reference variables? It's because they store not the objects as such, but the references to real objects. Thus, if right now we create a fourth box, call it box 4, and assign it the value of box 3 variable, there won't be any new box created. We will simply have two variables, box 4 and box 3, referring to the same box. To make sure it is so, let's change the height of box 4. It will be 100. As you can see, at this time the volume of box 3 is 1000. We have altered the height of box 4 variable, but since it and box 3 refer to the same box, the change will affect box 3 as well. Let's run the program. You can see that the volume of box 3 now equals 10,000. It happens so because both variables box 4 and box 3 refer to the same box. In other words, a variable simply stores a reference to an object. Our lesson is over. At home, you will create a class person. It will have the following fields: name, age, weight. Then within class main, you will create 5 variables of the human type. Assign values to their fields and print out the average age. See you in the next lesson.